hemorrhagic disease virus. And then the last one talked about pawpaw, whose extract for treating dengue fever and also cure the cancer of the uterus.
Okay. Okay, thank you very much, Kiremi, for presenting for group 2. Let's have group 3, Katua Wakahiga. Group 3.
Okay, in group 3 we discussed about aloe vera, which is used to cure skin diseases, neem tree the same purpose, and garlic the same purpose. Then we had mogoka, which is used by the locals in treatment of those guys with a lot of sleep. Yeah, and we have the ginkgo, which is used to boost brain health and slow down Alzheimer. And eucalyptus, which is used to treat cold in the rural areas. Thank you.
Okay, thank you, group 4. Sorry, group 3. There's something I didn't get to hear your last the last plant that you named.
I named eucalyptus.
No, not the last. Before the ginkgo. There's a plant before you named ginkgo. There's ginkgo, there's eucalyptus, but there's another one before ginkgo.
Oh, mogoka. The mira plant.
What is it for?
For treating people with a lot of sleep.
Who are those people? Are there people with a lot of sleep?
Yeah, there are those people with a lot of sleep.
I think people nowadays are looking for something to make them sleep, not to make them keep awake. Is that the only reason people take mogoka, really? And why do you want to keep awake at night? What are you doing?
There are people who work 24/7.
Yeah?
There are people who work 24/7 and they are required to have the energy and the concentration required, so they use it.
Yeah,
People like watching.
They just need to go to sleep when they need to go to sleep. I'm asking, is that the real reason why mogoka is used? Is that why people take mira? Who knows why people? Have you ever tasted mira, by the way? Yeah?
Not at all.
Not at all, or not a lot.
I don't know much about the plant.
I'm asking this because, sorry, I'm not putting you on the spot. Just mute your microphone a bit.
Okay.
I'm asking this question because for me, it defeats the purpose to want to keep awake day and night, and your body needs sleep. It needs to be rejuvenated. That's when you sleep, that's when your body gets healed, your energies get restored, and that kind of thing. Is there any other reason why people take mogoka and mira? Are there anything? Why do they take them and they look yucky? Does anybody know?
Okay, from what I'm getting from the internet, they say mira is used in treating diabetes, muscle strength, depression, fatigue, obesity, stomach ulcers, headache, and male infertility.
Okay, so those who take mogoka and mira, those are the benefits they get. Amazing. For those who have ever taken mira, does it make you feel high? Does it make you feel relaxed? Who's tried it? Oh, nobody. You're all good children. You've never tasted it. Oh, you are so good. Anyway, let's continue. So thank you very much, group 3. Let's hear from group 4, Nyale Sada. Nyale Sada from Group 4. Oh, he never came back. He just went. Who else was in Group 4? Was anybody else in Group 4 that wants to make a presentation? Okay. Anybody? Jaya?
Yes,
Go ahead.
yes, you can hear me, right?
Yes, you can hear you.
Uh, yes, in group 4, we discussed about basic things we find in our households like garlic, ginger, and lemon. And like ginger is used to treat sickness. People say that it is also anti-cancer remedy, and ginger is, you can also use ginger when you're suffering from cold and flu. The garlic is antimicrobial. Turmeric is used to prevent cancer. It fastens the healing of wounds. It is a remedy for good skin and control bacteria and control diabetes, and some people use turmeric as mouthwash. For lemon is used to boost immune system. You can also use lemon when you have cold. You can use to aid in digestion and to prevent heart failures. Lemon has a lot of medicinal benefits and also treatment of acne. You can use lemon in shampoos for hair nourishment and also prevent infections. That's what we discussed in group 4. Thank you.
Okay, thank you, Joy Alice, for presentation. So let's have the group, the last group, group 5, Louis Mwema.
Yes. So for group 5, we discussed using therapy as a form of medication for defects
Just
and
talk a little
treatment
bit more
of
loudly.
illnesses. So group 5, we discussed using therapy as a form of medication for defects and treatment of illnesses.
We mainly discussed using psychotherapy as a form of therapeutical technique for people suffering from depression, e.g. PTSD, like soldiers and people who have undergone critical issues. We also discussed using therapy sessions for recovering drug addicts who are trying to recover from addiction, and using therapy sessions for patients with mental illnesses. We also used therapy for regaining the function of joint and muscle memory for paralyzed victims who were involved in accidents or crash. Those are the points we discussed. Thank you.
Okay, thank you very much. I think now we are appreciating, we have actually hardly scratched the surface, on what nature offers us for therapeutics. And I think the fact that we are now so much into what do I call it? The chemicals, the chemical therapies. I think it would be good to appreciate that most of these have been developed from an original maybe molecule or what I'd call an active ingredient from a natural thing, or a natural plant or a natural animal in that way. Of course, once they go and do the synthetics, then things change. They add other things, they add other carriers. Some are not very good for human beings, some are whatever. But I think with biotechnology, it's now going to be even much easier, because actually they just use biotechnology to produce more and more of these probably like active ingredients and that kind of thing. And why, I tell you why most doctors or pharmaceuticals are not keen on using natural products. I'll tell you why. The reason is, for example, if you get something so good, maybe in turmeric that can cure cancer or can help with cancer management, you cannot patent such a thing because it is natural. You didn't discover it. It's there in nature. You cannot say, oh, now all cabbages or all turmerics, they are under me. There's nothing like that. So most of them will go ahead, maybe guided by what is in nature, go ahead and develop their own. And that is what they can patent. And you know, once you patent something, then you're making money out of it. So that is why we've got all these natural ingredients that at times you're like, okay, so why are we not thinking about this? Why are we not thinking about this? It's mostly because the economic interest is not there. But there are people, there are doctors like, the last time I had in Aga Khan Hospital, I had one doctor telling another, by the way, do you know now we are using honey to treat wounds? Yeah, just when you get authentic honey, which is clean, which has not been adulterated, it is so good in treating wounds. Even for diabetics, just applying that honey on the whatever, because it dries up the wound and it heals it so naturally. And so I was a bit surprised because that's a big hospital. They just know going for drugs from one drug to another, from one drug to another. But here they were just using just natural honey to address that, especially for people who had severe burns and that kind of thing. So, and even, yeah, as I said, diabetics. So the possibilities in nature are great, and maybe we'll come up with a way of being able to use all these natural ingredients in a way that they are going to benefit people. Yeah, we all having to add so many other things that at times end up being, of course, harmful to people. So let's look at vaccines. Can you see my screen now? Can you see my screen?
Not yet.
Okay. Let me share it. Sorry, I had stopped sharing. So can you see it now?
Yes. Yes.
Okay. Now, when you look at vaccines and the original vaccines that we have, vaccines that prevent some diseases like smallpox, measles, they were developed using a technology whereby used microorganisms, live microorganisms, or dead microorganisms were used. Smallpox jab, we either take a live live spot, sorry, small dead one, and you put it in a reed, and then you inject. So once injected, the body will react to that. It's a small amount, so the body will react. It will start fighting that virus. And once the body does that, what it does, it creates antibodies. So should a real virus attack you, your body will be prepared because it will already have the antibodies to fight it. So I think that is very, very good. Now, when vaccinated with such non-virulent, remember this microbe is so small, it causes you sickness. Okay, but it is going to help in production of antibodies. So when your body produces antibodies to that organism, then you get protection, but you don't get the disease. So as I said, if you're exposed to that microbe again, your body has already a supply of antibodies to defend itself. So what are the problems with vaccines? So generally, like, and I think this should now be an eye-opener to all of us. Generally, vaccines cause no serious problems, but they do have side effects. Some people may have an allergic reaction to a vaccine. Others may experience aches or pains or even fevers, that they are reacting to that vaccine. So that is given. And that includes all the vaccines you took when you were a baby, if your mother took you to the hospital, and maybe any other vaccines that you have taken as a grown-up. I know, like, there are those vaccines that are called DPT for, I don't know whether it's whooping cough or whatever. And mostly mothers know that once your baby gets that vaccine, for some babies it's so bad, they get pains, they get fevers, they will refuse to eat, they will raise hell for a couple of days. Yeah. So they are always prepared. You want, this might cause this, so be prepared. We have anti-fever medicine and that kind of thing. And you just be ready for a protracted time of crying. But finally it will settle. So the other, so that's the first problem. The second problem is that vaccination is consistent production of virus-based vaccine. Okay, so you're using the virus and developing vaccination for some deadly infectious diseases such as HIV and malaria is risky. I still don't know why it is risky. I haven't read so much into the vaccine. And probably this is why it's taken so long to have a HIV/AIDS vaccine. I know when COVID came up and fighting COVID, we were struggling, should we get it? And within months, we had the first COVID vaccine, Pfizer and Moderna, hey, we've got a vaccine. And then, of course, people came in, how have you managed to develop a vaccine so fast? And yet it's been years since the 80s that we haven't developed a vaccine for HIV, AIDS, for malaria and everything. And this went on and all that kind of thing. I remembered when all those arguments were taking place, I remembered the book I studied in literature, the short stories. It was in this story, I think it was not the government inspector, Betrayal in the City. And there's this one phrase that caught my attention since I was in secondary school, and it keeps popping up in my mind. And I kept saying, when the whole of mankind suffers, the individual does not suffer. And when some of the population is the one that is suffering, some people really couldn't be bothered. If you look at HIV/AIDS, where did we have the worst whatever? Of course, in Africa, in the poor countries, that is where we had the worst infections. Okay? That is where economies were being affected, children are being left homeless. It's not in the West, it's in Africa, it's in India, it's in those poor Asian countries. Okay, so you can almost imagine, we're doing some research, but so if it's in the US and whatever, most of the people that were dying were the gay people. Of course, the people, they don't, we should get rid of them in the first place. Okay, so people that are down there in the social scale. So you can almost imagine there was no urgency, much as well, there was interest. But you look around and say, is this thing affecting us? No, okay, they can wait a little bit more. But when COVID came, COVID is no respecter of persons, no respecter of countries, no respecter of, it doesn't matter your rank, it comes. Yes, it comes. And I think this is one of the motivations to quickly develop a COVID vaccine. And yeah, we have also seen, the other thing I think is because a lot of research had already started. They shelve it, oh, mRNA vaccines, oh, we are not sure, yeah, maybe we should shelve it. So I think by the time COVID came, they were like, all systems go now, this is our time and let's go for it. And yeah, there goes the COVID vaccine. Whatever your thoughts are about it, it is there. And yeah, so in vaccine production, mostly one or a few proteins of the surface of the pathogen trigger the production of antibodies. And by isolating the gene and inciting into E. coli, large quantities of proteins can be. I think we have already looked at this process, the recombinant DNA and that kind of thing, PCR method. So that one we are already familiar with. So when I talk about that, I know you already know what I'm talking about. So a large quantity of proteins can be produced to serve as a vaccine. When protein is injected, the body produces antibodies that can recognize the pathogen. And using these new techniques of biotechnology, scientists have developed vaccines against diseases such as hepatitis B and meningitis. So even the hepatitis B and meningitis are vaccines. Basically, they are biotechnologically based. Injecting naked DNA into muscles, naked means it doesn't have the outer coating, into muscles or skin cells, also elicits immune response. So before, I think researchers had assumed that DNA alone would not trigger an immune response to sufficient strength to impart protection against infectious diseases. But I think we are now seeing the difference. Right now it's mRNA vaccines. And at this point, I want us to get into groups for just about 10 minutes because I really about these vaccines because the vaccines are there. I don't know whether you have taken time to read about vaccines. Now you know a bit of biotechnology, you're not so green. I want to put you into groups. And what I want you to do, I want you pick a vaccine of your choice that you want to look at even more in more detail. You may decide to look for the Pfizer vaccine or the Moderna vaccine, or even the one that we have in Kenya. In Kenya, we have AstraZeneca. Very soon, probably we'll have many more. Okay. And I just want you to look at those. Choose one of your kind. It's up to you, to your group. Just say, what is the biotechnology behind those vaccines? Yeah? Look at the biotechnology behind it. So this is basically biotechnology. And tell us something about these vaccines. How have they been developed? We don't need the nitty-gritties, but we just want to appreciate biotechnology here because this is what you're reading about. And then at the end of the day, I also want, I want you to tell me what is your take as a group on those vaccines. Okay, so choose a vaccine of your choice. Tell us how biotechnology has been applied in their development and how they're working, and also tell us what you feel on it. So I've given you 10 minutes, and then we will resume. Happy discussions. Esther, you are in group 5, breakout 5. Joy Alice, you're in breakout 4. Omwenga, you're in breakout 3. Mohammed, breakout 1. I don't know what you're still doing on the main whatever. Omwenga, breakout 1.
Madam, I cannot see the pop-up to join the group.
Sorry?
I can't see the pop-up to inviting me to join the group.
I don't know, because that's I'm looking at your name here. When Kahiga is in breakout 3. I don't know what is wrong with your whatever, but yeah, Joy Alice is in breakout 4. Itadua is the only one who is unassigned, but the rest of you, Gadua and Joy Alice, you've been assigned. Joy Alice breakout 4, Gadua breakout 3. Okay, welcome back. Let's wait for a few others to step in, then we continue. I think you should tell your teammates to join quickly. Let's not waste time rejoining the group. The breakout rooms are over. We need the rest of the class in. I can only see 10 people so far. Where are the rest? Okay, I don't think we are going to wait for them. So group one, who was in group one, and tell us what vaccine you decided to whatever, just the overview. I don't need details. Group one.
Okay, in group one, we checked into AstraZeneca vaccine. AstraZeneca vaccine is produced in Australia, and it is said to be encapsulated in between lipids. And also its storage has to be within the super cold temperatures because it easily disintegrates. And among the components that make up that vaccine, we have the nucleotide modified messenger RNA, which is one of the active ingredients, and two lipid casing. And we have a salt, potassium chloride, sodium chloride, and dibasic sodium phosphate dehydrates, monobasic potassium phosphate, and we have cholesterol and sucrose, and also water for injection. Adenovirus, chimpanzee adenovirus, which is one of the new technologies, even in the field of biotechnology and vaccine development, and also the use of encased lipid layer, which is also new in the development of human vaccines. But it is said to train the body's immune system to recognize and fight the spike protein of the SARS-CoV-2, which is the virus that causes COVID-19. Yeah, that is what we were able to cover, and also the side effects that might come with the vaccine. The AstraZeneca vaccine is, to some people, it causes slight headache. Others, it will cause flu-like symptoms and also soreness. So most times, people who are allergic to some fluids and some of the ingredients that are used in making it, it might never be advisable to use for such kinds of people. Yeah, thank you.
Thank you, group one. The Oxford, the AstraZeneca vaccine, actually, as you say, it's the researchers added the gene for COVID spike protein to another virus called adenovirus. So it's actually a vector. You remember when we were talking, the very first lesson we were talking about a vector. A vector is a carrier. So this vaccine, they've added a gene from COVID, the spike protein of the COVID. They've added this to another virus called adenovirus. So the adenovirus, these are common, they are common viruses like flu or cold, whatever. So they modified the version of the chimpanzee adenovirus. And now actually that is, so this virus can enter the cells, but it can't replicate inside the cells. Okay, but what is this virus carrying? It is carrying the COVID-19 spike protein, that protein. Remember when you're talking about a gene, you go for a particular gene, and that is what, so that spike protein in the COVID-19 is the one they have taken, put it in the chimpanzee adenovirus, and now that is what now, this cannot replicate through inside, okay? But once it gets into the body, then it now teaches the body, it produces the antibodies because that virus, the COVID protein is there. It starts producing antibodies against whatever. And that's why I don't know how much you've read about these viruses. Some people with like who are taking immunosuppressants some have taken the vaccines and they have gone back and just to see is the vaccine working. So you go for you test for COVID antibodies, and for some they found that there are no antibodies probably because the medicine they are taking is so low. So, and when you don't have antibodies, that means then you don't have protection. So let me not go so much into that. Let's listen to group 2. Group 2, tell us the vaccine you chose and tell us more about it. Is there no one from group 2? Anybody from group 3?
Okay, for group 3, we focused on the Moderna vaccine. Joined later, but I had to catch up with others. We get to know that the Moderna vaccine is an American pharmaceutical and biotechnology vaccine, and it's used to insert the nucleoside, and it's referred as to the modified messenger RNA that inserts the nucleosides into human cells using a coat of lipid. This vaccine, it reprograms the cell to immune responses. We also realize that the vaccine is delivered in lipid and that it's designed to improve translation. The same vaccine is also used to fight coronavirus, but it's not tested and it has not been put into action because there is the AstraZeneca vaccine. And the vaccine also, the Moderna vaccine also makes other vaccines that cures 24 diseases, such as season flu, HIV, and Nipah virus. We also saw that when you are given the second COVID-19 vaccine of the Moderna, it will be easier to store and administer the other vaccine, and that has not been put into action well. I think that's it for group 3. It was a short discussion.
you. Thank you. I really wanted to hear about just the constituents and the biotechnology behind it. Okay, for me, that's the most important thing, and it looks like you have addressed that. So thank you. Group 4. Group 4. Where did all these people disappear to? Michael Fares, which group are you in?
Group 1.
Muchembi said, which group are you in?
Group 5.
Group?
5.
Okay, let's hear from group 5.
So in group 5, we were discussing.
Your voice is so low.
My phone has a problem. Can you hear me?
Yeah, you can hear. Endelea tu.
In our group, in group 5, we have been discussing on the polio vaccine, that is the inactivated polio vaccine, and we found that this vaccine was produced in a wild polio virus that was activated by a family, which helped to produce this vaccine that mostly is injectable. It's usually injectable and it's injected alone, not as any supplement. And it has been tested in different countries like Netherlands, and it worked. So we found this vaccine, its main aim to suppress the serum virus that usually brings some paralytic effect in kids, those who are under 5 years. So we found that when they get administered this vaccine, it suppresses the heat of that virus when it affects kids. That are associated with this vaccine, we find that there is a mild transmission.
Are you done? Said, okay, I really didn't hear much. So, but I know you are talking about the polio vaccine. I don't know whether they've developed another vaccine, but generally, I think polio, they were just using the original way they used to make vaccines by using either a live or a dead virus to stimulate the immune system of the body. So I think let's proceed. I didn't hear from those other two groups, group 4. Group 4, Nyale Sada, I know was in that group, but I didn't hear from them. And group 3, I also didn't hear from them. Kenganyevu, Gadua Kahiga, I didn't hear from them. I just let them know it was noted.
In group 4, madam, I was in group 4.
You're in group 4?
Yeah.
Yeah,
so in group 4, we discussed about the measles vaccine, that is the MMR vaccine. This vaccine is developed by the use of a viral that is used to stimulate the immune system. So it is attenuated by an injection at the upper arm of an individual to initiate the immune system to produce the antibodies to fight the disease, that is. So the main adverse effects of the vaccine is that the side effect, that is, it develops the mild rashes and fever on the patient. Yeah, that is what we discussed.
Okay, thank you, group 4. Why was insisting on the COVID vaccines is because now there's a lot of biotechnology in the COVID vaccines. I still don't know. So it looks, nobody looked at Pfizer, and Pfizer and Moderna more or less use the same technology. Johnson & Johnson, I'm still not very sure, but yeah, I just wanted you to appreciate the applications of biotechnology even today. And like in the last 1 year, what has happened? Now I want to ask an open question. What's your view on the vaccines? Has anybody taken a vaccine in this group? Has anybody been vaccinated? No? Okay, in August, we are going to have vaccines, hopefully, and I think it's going to be really opened up for people to have vaccines. What's your view? I want to know your view. Omwenga Derek, what's your view on vaccines? Are you going to get a vaccine, COVID-19 vaccine? I mean, I just want you to because it's in application now that we know what those vaccines are about. What do you think? Amwanga Derek.
Okay, as for me, my dad took the vaccine. Yeah, he's said to take the next vaccine. Nothing has happened. I think personally, I can go my parents' way. If the vaccine is going to be open, I'll take also one.
Thank you for your views, Derek. Who else wants to talk? Okeri Nyamoita.
Yes.
What's your thought on vaccines?
Since the vaccines are made to protect someone from being infected by that disease, I will take the vaccine if it comes and if it's open. Yes.
Okay, thank you. Is there anyone who thinks people should not take the vaccine? Mwandikwa, what do you think? Oh, Muchembi said has raised his hand. Go ahead, Muchembi.
Yes, according to me, the current COVID-19 vaccine, I'm not so contented with it because there is a lot of controversies behind it. You see, many people are arguing that there is still not clear information about it. So for me, I think we still need more time to research so that we can come up with something.
Okay, Seth, sorry, I can't hear you clearly. But are you saying there is not enough research that has been done and therefore they still need for more time? Is that what you're saying, Seth?
Yes, there is a lot of things.
Oh, okay, fine. So for Seth, not yet, he's not yet ready. Who else wants to say something? Michael Fares? Michael
I think I would say that there are so many uncertainties in relation to the information available and, in comparison to the vaccines we have. So for me, it's still a no-take zone.
Okay, so for Michael Fares, I think he needs more information for him maybe to build confidence and yeah. Anybody else? Anybody else? Peter Duo? Peter Duo, uko, you disappeared. Okay, Owino Clifford?
I'm not on it because of the rumors I hear, and I'm one of the people who have allergic reaction. So when I take the vaccine, it can impact my health negatively.
Okay. For Clifford, he says he has allergic reactions, and we can already see that is contraindicated, if you normally react to vaccines, then you should not take the vaccine. Let us see someone is Malevi Kitome. Are you there? Malevi?
Yes, I'm there, madam. Yes, I'm
What's your
there.
take?
For me, I cannot take it now. Maybe I see my friends such as Derek. I see their reaction.
Okay, so you're waiting for the others to take, and then you're watching from a distance and you see what happens to them. And then
Yes.
say, hey, Buana, this thing, no, not for me. Okay, that's interesting for Malevi, the wait and see. Anybody else who has a view that they want to share? Okay. So I think for vaccines, for me, I think, so this is my take. When COVID came out, we had 100 or more theories as to why COVID came and what COVID is. And some called it fake. And I read through all those. And this is fake. This is as a result of 5G. This is sort of biological warfare. All that. You can imagine from March last year, a lot of water has gone under the bridge. And yet with time, I think there are some facts that have been established. And one of the biggest facts is COVID is real. COVID is real. But I think that one now, we are no longer there where we began, we have established. So that means there were a lot of conspiracy theories that were presented. And people, and we have internet now, so people will say all sorts of things. In fact, today I was reading something and they were saying they have traced that most of the COVID misinformation actually came from 12 people, like globally. So I don't know who those 12 people is. Anyway, so people, oh, there's no COVID, nini. And then, wow, there it was, there is COVID, actually COVID vaccine. So let me tell you, now I'm telling you a personal story. Then, so fine, a vaccine was developed and people started getting vaccinated. And then when the vaccines came to Kenya, there's this person in Kenya, a very, very good doctor. And he said, I think he was a Catholic. And he said, oh, you guys, you don't need to take the vaccine. The vaccines are unnecessary. And you just need to take some drugs. There was there's erythromycin, there is hydroquinone. You can also take another, get the name, and you'll be safe. And you steam and you take vitamin D and everything, and you'll be safe. And to me, that sounded nice. And I said, oh, then you don't need the vaccines. These people are telling us to take vaccines. And of course, you know the theories behind the vaccine. Go through the and okay, luckily, I belong to a group, so maybe very high ranking, some of them who were some of the top virologists in the world, and they're part of that group. And when these discussions came, I must say I was very, very lucky to just get very, very professional discussions concerning the vaccines. So number one, they dismissed the issue of the chief being in the vaccine and all those other things. They say, come on, we produce vaccines, and this is how vaccines are produced. You say, don't buy any other theory. So for me, it really helped put things in perspective, and it helped get my science right when it came to vaccines. Okay, so now, I was still gathering information, and then so this guy says, oh, you don't need vaccines, just take this medicine and you'll be okay, you'll be fine. Then you know what? One day, the other one was ivermectin, which is a parasitic, whatever. One day I wake up in the morning, I'm just going through news. I said, this man, he was a doctor, a really good doctor. He had passed on from COVID-19. I really was shocked. I was like, oh dear, what happened? So then I was like, then you have to really rethink your stand on vaccines. You really have to rethink your stand on vaccine. And don't forget science. I mean, and for me, for me, that was my turning point. And I was like, okay, fine. I think for me, then I'm making a decision. I'll not tell you which decision I made. So I think it's very, very important for whatever decision you are making, make sure you have the right information, And that's why I was provoking you to read about these vaccines. And even beyond this class, go ahead and read about them. And not just about the vaccine, but also things like biotechnology. For example, for me, things like GMOs. I'm not taking it. I don't take any GMO plants at all. There are things that I avoid, and I'm not taking them just because I know what they could be having. You see, so read the science, understand the science. Then from there, make a decision. Remember, I always tell you, don't make emotional decisions, make decisions based on knowledge. It could be social, it could be science, whatever it is, it could be economical, but make decisions based on adequate knowledge that you have taken time to acquire. So whatever decision you will make, then you say, I can stand by my decision. I know the knowledge, and you got it. Let's continue so that we can finish this. Any other comment? Okay. So we are looking at vaccine delivery systems. I think we have already looked at that. Vaccines being developed as a live virus, a coat of protein or a piece of its DNA, the production of these vaccines require very, very costly facilities and procedures. That is why you're seeing, like in Kenya, we're still not producing vaccines. We were so dependent on India. And when India says, come on, we come fast, we were sort of thrown into a limbo because we depended so much on the Serum Institute in India to produce our vaccines. And for me, I think this is good for now because it's a wake-up call for Africa. Wake up and have your own vaccine-producing herbs where you can produce your vaccines or you can package your vaccines. I know Kenya is already thinking about that. Moving forward, that is very important. And they're saying especially for some vaccines like, I think the measles and the smallpox, which are not patented, you cannot go ahead and produce them. And even as we are talking this, remember Kenya produced the rinderpest vaccine. You know, at times tunajisahau sana. Yes, Kenya is the one that produced the rinderpest vaccine, I think, which is used all over Africa. I don't know where else. So let's not get lost in all this. Let's get our knowledge right. And also let's see what are the possibilities for our country. So now, because of these very difficult whatevers of producing conditions for producing vaccines, industry researchers now are using biotechnology to produce edible vaccines. I remember me talking about an antigen in goat milk that can help you and protect you from malaria now. And I think this one of edible vaccines, I've heard of it. It's there. If you've been reading a lot about vaccines, it's there. And I think some companies are actually taking it up. Instead of just getting the jab, it's something you can eat and kusha maneno. Of course, there is the genetically engineered goats to produce malaria antigen in milk. And there are also positive results that have been shown for human volunteers who consumed hepatitis vaccines in bananas and cholera vaccines in potatoes. So I'm saying these things just to provoke you to see that the possibilities are sort of endless. There are so many. When it comes to plant agriculture biotechnology, I think we have looked at this before. And we're saying modern agricultural biotechnology includes the genetic makeup of organisms for use in the production of agricultural products where they applied. Microorganisms have been used for decades to produce antibiotics. We know them: penicillin, streptomycin from bacterium, and so in plant agriculture, plants are genetically complex, yeah, and there is a lot of advancement now in biotechnology. Before, I think the priority was medical, but now I think agriculture now has its fair share of interest, and that animal research also has received a lot of whatever, like in the US, this is federal funding in the US than plant research. So there's also a lot of research into animal biotechnology in the US. In Kenya, sijui tuko wapi, maybe I'll need to check. So we know from our previous lectures that biotechnology has been used to protect crops. It has given opportunities to farmers to work with nature. Scientists have discovered some plants and animals that have endogenous defense systems. So, and they are using this now to try and see, can they help the other plants to do that? You also have scientists developing environmentally benign chemicals that can also be used to develop defense to plants. Normally, the plants, the chemicals that we use for protecting our plants are very, very hazardous. They are chemicals and they are bad. They're bad for human beings. So it's true, you keep away, you make the plant strong, but finally the person who's going to eat the plant, be it an animal or a human being, is going to suffer. The issue of biological control or biocontrol, this one is there. I mean, this is natural. This is non-gene biotechnology where you use suppression of pests and diseases through the use of biological agents, maybe through a beetle that will eat the pest and that kind of thing. A virus may also be used to control an insect pest or a fungus and that kind of thing. So if you look at nature, before we came, nature had its own way of balancing things to make sure that this insect does not overgrow. This insect does not overeat these animals, because this insect is now being eaten by another organism. So it is going to eat a bit of the plant, but it's not going to overeat the plant. So nature had its own balances. But in comes man, our chemicals and whatever else we do, and we upset that balance. So is it possible to learn from nature and go back? How was nature dealing with predation? How can we use predation and parasitism also to help farmers to use biological control for pests instead of going for chemicals? Okay, I know that is already being practiced. The issue of symbiosis, where some plants have nitrogen-fixing bacteria like the legumes. And this is very beneficial for the legumes because then they have a production of nitrates, which they use and they grow well. So scientists are finding out, is there a way to understand the genetic basis of this symbiotic relationship so that you can give nitrogen fixing capabilities to other plants apart from legumes? Amazing. Then there's also the nutritional value of crops. Now there's a lot that is happening. For example, the BT corn, they are saying they are, when BT corn is grown, it is less affected by fungi. We know one of the worst fungi for BT corn is aflatoxin. And aflatoxin is bad for both livestock and human, but BT corn is able to withstand that. more, but there are other things now about beautycon that you're not very sure of. There is also biotechnology that has been used to come up with a plant that will meet the needs of the consumer. For example, now they're trying to develop healthier cooking oils. You know that most of our cooking oils, which we use, okay, they look very good. You say, oh, I'm using vegetable oil. Yeah, most of our vegetable oil, by the time you heat them to the temperatures we heat them when you're cooking with them, they are producing what we call trans fats, and that is very dangerous, but nobody tells us about it. Okay, nobody tells us about it, but yeah, we are here heating our oils, nakanga kituguhujo, putting your temperatures very high. But what happens in the process, the oils reach their smoking point, they are transformed into trans fats, and trans fats are bad. So the scientists are trying to see, can they develop healthier cooking oils? Okay, and all these things. I told you the possibilities are endless. I think I want to stop there for today. And before I think I want to announce a card. This card will not be, you'll do it at home. It should be submitted next week. I'm going to put up the topic, and I'll give the instructions, work on it. It should be I'll tell you when you should submit it. And that is going to be your part one. Your part two, God willing, will do it in person. When you come back to prepare for your exams, that is when we'll do part two. So get ready, get prepared. I'm going to immediately after this lecture, I'm just going to send in your email what the card will be about. Tell all those people who are not there, I don't want excuses, I don't want reasons. I'm giving you almost a week to work on it. No, and once you work on it, send it to the class rep. Don't send it to me. The class rep will send you one file. That's it. I'm not going to take late entrances and all those things. I'm not going to take them at all. So immediately after this, maybe 15 minutes after this, make sure you check your email to get the cut and to start working on it. So I think we stop there. We start again at 1:30. 1:30 for our, actually 1:30. Let's start at 2 o'clock for our afternoon lecture, 2 o'clock for SMR 408, because we are also winding up also in that. So thank you. Is there any question?
Excuse me, madam. I am requesting if you can clarify on that part of cut.
So what do you want clarified? It will be a personal, everybody will make their own personal submissions. Okay, but I'm going to give the details in the email. So bado sijawaambia topic.
I was kindly requesting
The notes.
the notes. Yeah.
But you don't read them.
We do.
We do.
Do you read?
We do read them.
I'll send them. From which topic?
From
From topic?
6.
No. I've sent from 6.
From last week's lectures.
Yeah, the rest I've sent. So you see, you don't read.
So the last ones we saw was topic 6, and then the other reading materials. So
you don't
most
have topic
basically,
7 and 8 and 9? Okay, 8 and 7?
yeah, we don't have those ones.
So I'll send them. Any other issue? Okay, so let's meet again at 2 o'clock. Enjoy your lunch.
You too.